Welcome back. So one of the most important things in networking is this thing called an OSI model. And there are different layers. We definitely need to talk about how this works, what happens at every layer, and understanding how data goes up and down the model and how it gets routed everywhere. So let's take a look at the OSI model, and we're going to compare it to this other thing called the TCP IP model. So there are two that are important, and the one that we're going to focus on the absolute most is the OSI model. And we're going to take a look at this from the bottom up. So starting at the physical layer and working our way up to the application layer. Now there's lots of ways to help remember what this thing means as far as what each layer is called. And you can do this bottom up or top down, totally up to you. And two of the easiest to remember and the most appropriate, so I can actually share them, are the pizza models. So take a listen to this sentence and one by one match them up to the layers. Please do not throw sausage pizza away. So from the bottom up, if you say that sentence, each of those words have the same first letter of each of the layers. Please do not throw sausage pizza away. Now, if you prefer a top-down method, we can start with A and go down to the physical. So we can say, all people seem to need delicious pizza. Whether you're a top to bottom or bottom to top person in regards to memorizing this, those are two easy ways to make it happen. So on the more serious side, let's talk about what these layers are and how do they affect us on the networking side. So I'm going to start at the very bottom, which is the physical layer. And this is layer 1. The basic functionalities are, it has all the physical cabling, all the physical connectors, the signals. It's responsible for light signals, radio signals, whatever type of actual media is being transmitted. This is where all of the hardware lives. So the devices here are your hubs, cables, any of your Ethernet cables, your repeaters, they all work on this layer. Now, layer 2 is the data link layer, and there's some basic functionality here that you need to understand. All of the encoding and decoding that lets electrical signal turn into bits, the ones and zeros. It manages data errors that are created at the physical layer. It converts all electrical signals into these things called frames that we will talk about in a different video. The data link layer is actually subdivided per se into two layers, and the one that you're going to hear the most is the MAC section, the media access control. And this is the first layer where we're really concerned with addressing. And layer 2 addressing, or MAC addressing, is your media access control MAC address. That's your media access control address. And what does that mean exactly? Well, this is a physical address that goes with every device that is on a network. And you need a MAC address to be able to get onto a network. Now, the MAC sublayer controls how a computer on the network gains access to any data and permissions to transmit data. The LLC layer, which is the second sub-layer per se within layer 2, controls every frame's synchronization. So the flow control and air checking and how all of this good stuff moves. LLC stands for logical link control. Now the device that is associated with layer 2 is going to be a switch. And if you've seen the network device and hardware section of our class, you know all about a switch and how it works and how we plug into this thing. So layer 3 is the network layer, and this is where routing takes place. All of your routing technology, your logical paths between two hosts, whether they're right next to each other or they're across the entire world, this is what allows us to use virtual circuits to connect any two devices. All data is routed per packets. There's an IP address that we're concerned with at this layer, an internet protocol address. What's handled here is all of our internetworking, more air handling, any congestion control or sequencing of packets, meaning what order they're sent in and how to get them all put back together. That all happens at layer 3. Our transport layer, or layer 4 of the OSI model, is responsible for all of the data between systems. That means we have end-to-end recovery, more flow control happens here as far as what protocols are going to be used. And there are two acronyms that you're going to want to remember, and that is UDP and TCP. Now, UDP stands for User Datagram Protocol, and TCP is a transmission control protocol. Imagine it in one of two ways. If we were throwing a baseball back and forth, and I caught the ball when you threw it to me, and then I got the ball out of my hand and threw it back to you and waited for you to catch it. That means that we are in a TCP session because I am waiting for the acknowledgement that you caught the ball, and you're going to say, oh, good throw, or wow, you suck at throwing, whatever it may be. And I'm going to know that you actually caught it or went and retrieved the ball. Now let's switch that over to a UDP example. Imagine if I caught the ball, threw it at you, and turned around and walked away. I don't know if you caught it or not. I don't know if I threw it short or way too far. I'm really not concerned with it, to be honest. All I knew is that I was responsible for throwing it towards your general direction, and that was the end of my concern. So very, very different ways of sending data, and that's what UDP and TCP are responsible for at the transport layer. Our session layer is layer 5, and it's responsible for the establishment, management, and cancellation or termination of all sessions or connections between different applications. So when you want to create a session and communicate with a different device, all of that's being negotiated and managed in the session layer. So it sets up and coordinates these conversations and the exchanges of data with different applications on both ends. It deals with connection coordination, and you'll hear a lot about NetBIOS naming and SQL work at this layer. If you don't know what those are, come into your A+ networking classes, or you'll get a much deeper understanding when you start heading towards your Network Plus certification. So again, this is all about networking. This is getting data from point A to point B. The representation layer is layer 6, and it's responsible for the data on your screen. Now, it's not actually what you see, but it's the representation that your computer understands. So it's encrypting and decrypting data. It has all the syntax and the languages that your computer understands. So, you know, when you open a picture, it might be a JPEG, it might be a PNG file, maybe you're opening a GIF, GIF, or GIF, however you'd like to say it. Those are the things that are understood by our computer. We honestly don't care too much what the file extension is. We just want it to open and we want to see it. But your computer very much so cares. And this is where it figures out what it's trying to open and how to do so. Now, what we actually see is the application layer, and that's layer 7 of the OSI model. It supports applications and all of our processes as an end user, and this is where we are able to interact with data, meaning create data or tell data to go somewhere, meaning file transfers, emails, any software that we involve ourselves with. We also are at the receiving end of something we call QoS, which is quality of service. And that's the full set of protocols and the service that allows us to tell different applications who has priority. So if you're trying to stream a movie, that might need a lot more bandwidth than trying to shoot an email out. And it's more important for us as an end user to make sure that our movie isn't buffering all the time or skipping through different sections. So we're going to tell it that it has priority on the bandwidth of my system so that I can get a smooth functioning stream. So that is a quick overview of the OSI model. Let's take a look at how that compares with the TCP IP model. So on your screen, we're pretty much been focused on just the center, right? The 7 layers of the OSI model. The TCP IP model actually only has 4 layers, but they cover all the same things that the OSI model does. Now, the first 3 layers, or the top 3 layers of the OSI model, equal the top single layer of the TCP IP model. So application, presentation, and session equal the application layer of the TCP IP model. Transport is the same one for one all the way across. The network layer is renamed here to the internet layer in the TCP/IP model. And the bottom two layers of the OSI model, physical and data link, are both housed within the network access layer of the TCP/IP model. Now, as you go through troubleshooting situations, different exams on your practice tests, you will see questions that ask, what layer of the OSI model should you be looking at to solve this type of problem? Or, we've already looked at this layer and that layer. What is the next best option for a tech to move forward with troubleshooting? And they may be referencing either the TCP/IP or the OSI model. Now, for further information on this, I want you referring to a few different places. One, we have a lecture that goes much deeper into this that you'll come across in the next few videos in your class. But two, in your book, there's a breakdown of the OSI model, and it gives you much more information in depth into what processes happen and what protocols occur at each layer. And understanding those are definitely important. Now, the one thing we will not go over in this video, but we will in a video about 2 sessions from now, are what you see in the data column. You'll see that data actually changes names, and that's very true, but more importantly, it changes sizes. So as data flows down the OSI model, it's going to be broken up into different chunks per se, and each one of those chunks has a different name. So that was a quick overview of the OSI model and the TCP/IP model, and just a little bit about the different kinds of data chunks that are encapsulated and decapsulated as we send data throughout our networks. Are you ready for a practice exam? Keep studying hard, and we will have you test ready in no time.